Hi, my name is Virapat Pinmanakam. This video presentation is about Chapter 3, Transport Layer. User Datagram Protocol, or UDP. The User Datagram Protocol is a connectionless, unreliable transport protocol. It does not add anything to the services of IP except for providing process-to-process instead of host-to-host communication. UDP is a very simple protocol using a minimum of overhead. UDP packets called user datagrams have a fixed size header of 8 bytes made of 4 fields, each of 2 bytes, 16 bits. The first two fields define the source and destination port numbers. The third field defines the total length of the user datagram, header plus data. The 16 bits can define a total length of 0 to 6500 and 65,535 bytes. So this is a user datagram. So it has header and data. Header is 8 bytes. UDP service. So it is process-to-process communication using socket addresses, a combination of IP address and port numbers. Connectionless services. An independent datagram, not numbered, no connection establishment and termination. Setting short message just less than 65,507 bytes. No flow control and no alert control. Uh, Checksum congestion control, no congestion control. Encapsulation and decapsulation. To send a message from one process to another, yes. Queuing. UDP queues are associated with port. At the client side, when a process starts, it requests a port number from the operating system. Incoming queue and outgoing queue. Multiplexing and demultiplexing. Yes, only one UDP but possible several processes. Pseudo header for checksum calculation. UDP applications. Although UDP meets almost none of the criteria we mentioned earlier for a reliable transport layer protocol, UDP is preferable for some applications. The reason is that some services may have some side effects that are either unacceptable or not preferable. An application designer sometimes needs to compromise to get the optimum. In this section, we first discuss some features of UDP that may need to be considered when one designs an application program. UDP features: connectionless service, lack of error control, and lack of congestion control, and typical applications. Not used for a process such as FTP sending bulk data, TFTP or trivial file transfer protocol, multicasting embedded in the UDP software, management process such as SNMP, some route updating protocols such as routing information protocol, interacting real-time applications. Next is Transmission Control Protocol, or TCP. TCP is a connection-oriented, reliable protocol. TCP explicitly defines connection establishment, data transfer, and connection teardown phases to provide a connection-oriented service. TCP uses a combination of GPN and SR protocols to provide reliability. TCP services. It is a process-to-process communication using port numbers. Stream delivery service, sending and receiving buffers and segments. Full duplex communication, data can flow on both directions at the same time. Multiplexing and demultiplexing. Yes, and a connection needs to be established for each pair of processes. Connection-oriented services. Establishment, data exchange, and termination. Reliable services. Uses an acknowledgement mechanism to check the safe and sound arrival of data. So this is a stream delivery of TCP. Sending and receiving buffers. TCP needs buffers for storage using a circular array of 1 byte location. TCP segment. TCP group a number of bytes together into a packet called a segment. TCP feature. Numbering system. Byte number. The byte number is the bytes of data being transferred in each connection are numbered by TCP. The numbering starts with an arbitrarily generated number. Sequence number. The sequence number of the first segment is the ISM. The next sequence number is the sequence number of previous segment plus the previous segment. No, is the sequence number of previous segment plus the data segment. Segment is a packet in TCP. A TCP encapsulated the data received from the application layer. Control field. So it has URG or urgent pointer is valid. ACK or ACK acknowledgement is valid. PSH is request for push. RST is reset. SYN is synchronized sequence numbers, and FIN is terminated connection. Pseudo header added to TCP datagram. A TCP connection. TCP is a connection-oriented. As discussed before, a connection-oriented transport protocol establishes a logical path between the source and destination. All of the segments belonging to a message are then sent over this logical path. Using a single logical pathway for the entire message facilitates the acknowledgement process as well as retransmission of damaged or lost frames. Connection establishment. It is three-way handshaking. Scene flooding attack. Data transfer is push data and urgent data. Connection termination, three-way handshaking and half close. Connection reset. So it is connection establishment using three-way handshaking. Data transfer. So it is three-way handshaking too. This segment cannot carry data and consumes no sequence number. Half close. State transmission diagram. To keep track of all the different events happening during connection establishment, connection termination, and data transfer, TCP is specified as the finite state machine or FSM as known in figure T.51. Windows in TCP. TCP uses two windows, send window and receive window, for each direction of data transfer, which means four windows for a bidirectional communication. To make the the discussion simple. We make unrealistic unidirectional. The bidirectional communication can be inferred using two unidirectional communication with piggybacking, send window and receive window. So this is send window in TCP. This is receive window in TCP. Flow control. TCP separates flow control from error control. Opening and closing windows. Shrinking of windows. And silly window syndrome. Data flow and flow control feedbacks in TCP. This is example of flow control. Error control. TCP is reliable transport layer protocol. This means that an application program that delivers a stream of data to TCP relies on TCP to deliver the entire stream of the application program on the other end in order, without error and without any path loss or duplicated. Checksum. Check for corrupted segment, detected, discarded, and lost segment. Acknowledgement to confirm the receipt of data segment. So it has cumulative acknowledgement and selective acknowledgement. Generating acknowledgement retransmission after ITO and after 3 duplicate ACK out of order segment. FSM for data transfer in TCP. In some scenario. Rule 1. When NA sends a data segment to NB, it must include piggyback, piggyback, and acknowledgement next expected sequence number. Rule 2. The receiver needs to delay sending an ACK segment if there is only one outstanding in order segment. Rule 3. They should not be more than two in order unacknowledged segment in any time. Rule 3. They should not be more than two in order unacknowledged segment at any time. Rule 4. When a segment arrives with an out-of-order sequence number, the receiver immediately sends an X segment announcing the sequence number of the next expected segment. Rule 5. When a missing segment arrives, the receiver sends an X segment to announce the next sequence number expected. Rule 6. If a duplicate segment arrives, the receiver discards the segment, but immediately sends an acknowledgement indicating the next in order segments expected. TCP congestion control. TCP uses different policy to handle the congestion in the network. We describe this policy in this section. Congestion window, congestion detection, congestion policies, policy transition, Tahoe TCP, Reno TCP, and near Reno TCP. Additive increase, multiplicative decrease. Slow start and exponential increase. Congestion avoidance and additive increase. Thank you for watching.